Okay, so I don't have any prepared slides today. I'm just going to go through a bit of a demo using OpenLiberty and OpenJ9 to show off some of the shared classes and AOT technology that we've got and how you can understand a bit about how it's operating and what's being stored there. So I've just started a standard OpenLiberty web profile Docker container here, just a standard one. I've set up a Docker shared volume here so that I can get OpenJ9 into that container and use OpenJ9 to run OpenLiberty. I started off by just setting up some configuration stuff so that I can access OpenJ9 very easily and verified with a Java Dash version that I am using Eclipse OpenJ9 as the JVM. Sitting in this directory here is where the OpenLiberty server can be started. There's a nice little script called server. So what I'm going to do is just start that to show you that it can work. And let's time it. Oops, let's time it. Not tie it. Of course. I have to stop it first. Sorry. Demo jitters. There we go. So let's just start it here. And in a few seconds, okay, so that is the default server start time for the Liberty web server profile running in this Docker container on my MacBook, et cetera, et cetera. Mileage may vary if you run it on a different system. So this is not using shared classes. This is just the default startup JIT heuristics that OpenJ9 is using. But that's not the best that you can do. So the first thing that we can do, let me just I have to do another preparation that I didn't do. It's actually supposed to come later in the talk. But anyway, okay. So I was going to verify that this does not use any cache. Okay, so we can see this list all caches is a subcommand that you can use from Java, which will list any shared class caches that are available on a system. Because I just destroyed that one, it's no longer there. Let me just do a quick proof that I wasn't using that cache before. Hopefully we'll get a number that's around the same ballpark quickly. All right, so 6.9 seconds is about what I'm seeing on my system to start up. So what if we wanted to make this faster using our shared classes technology? So the way that we would do that is stop the one that's there, and then there we go. There's a way of passing in JVM args to the server script, and we can just say share classes, and that will run with the shared classes technology. Now this is going to be a first run. And we actually do a bunch of more aggressive things during the first run in order to prepare to make startup faster. But of course, that has the end result that startup got a lot slower. So here we're at 8.4 seconds compared to 6.9 seconds. So yeah, good job. But if we stop this server and run it one more time, again, using the shared classes option to make sure that it's going to connect to that same cache that it just created, we should see the demo gods have been prayed to appropriately. Okay, so we're down to 5.1 seconds, which is a pretty good improvement already, even on 6.9 seconds. So let's go see this cache that we created. So list all caches is now showing that there's a cache here called shared CC root. You can actually name your cache if you want to give it its own name. You can have multiple caches on the system and then use the name option to connect to them. But I'm just going to use the default one, which just uses a default name and connects the username that's being used to access it. And we can find out a little bit about what's in that cache by using the printstats command. So this is a very simple command, just shows a summary of all the contents that's inside the cache. Some of it is easy to ignore, like the nice little pointers that get stuck in here. But it starts, these stanzas here get a little bit interesting. So we have a cache size of 16 megabytes. That's the default shared cache size on Linux. This is an interesting line here, free bytes equals 0. That means that there's no space left in this cache. So I'm going to come back to that in a sec. But there's a couple of other things I just wanted to point out while we're looking at stats. So classes, affectionately known as ROM classes here, there's about almost 11 megabytes of classes being stored in the cache, and a little bit more than 3 megabytes of AOT, compiled methods. Now, what is this AOT compiled methods? In OpenJ9, the JIT compiler can actually decide to store the compiled code that it generates as a relocatable code body into the shared class cache that can be reused on a subsequent JVM execution. And what that means is that you can avoid having to do all the effort and spend the time and CPU resources and memory resources to do compilations to compile native code, and instead you can just load that code out of the cache, and that is a lot more efficient, on the order of 10 to 100x more efficient to just load that code from the cache than it is to perform a compilation inside the JVM. And so that's why you can get a big startup improvement, from that. Plus, all of these classes that are being stored here are stored in an internal format that's closer to what the JVM needs when it's loading classes. So when you have a class loading intensive application like an app server that's starting up, you can save quite a lot of time just by having these classes in the cache, and also the AOT code being stored in the cache as well. There's some other stats down here at the bottom just to give you the numbers. So it's not just, this is bytes of memory. This is the number of classes and the number of methods. But I pointed out that the free bytes is 0, so that means the cache is full. So immediately that makes me think, if it's full, maybe there were other things that I could have stored in this cache if it was a little bit bigger. So let's get rid of this cache. You can do destroy. So now we can verify that, oops, that's not what I wanted to do. I'm trying to go too fast. It just created a new one. Okay, let's destroy it again. Okay, slow down. There we go. Okay, so we no longer have any shared classes on the system, shared caches on the system. Let's do server stop just to make sure we're stopped. Okay, now the default cache size was 16 megabytes. So why don't we try doubling that, which I actually know is a reasonable size to use. So that's the -XCMX32M is the option that sets the maximum size of the shared class cache size. And so that's going to start our guy, and he's going to be slow again, remember, because this is the first run. Right? And then we stop and restart again. Now, technically, I don't actually need to set the size this time because the cache has already been created, but I'll just leave it there to save time. And now we're down below 5 seconds. When I did the demo earlier, that was actually a bigger improvement. But let's go see what's inside this cache now. There's my print stats. There's my print stats. So you can see this is now a 32 megabyte cache, and I've got 11 megs free. So I actually got quite a lot more space in the cache, but I'm no longer free. So I've used as much as I need for the startup of this particular application server. That meant I was able to store 13 megabytes of ROM classes and another megabyte or so of AOT code. So that's even more code and even more classes that I can use to accelerate startup, which is why I was expecting a little bit more of an improvement, but maybe it's just the Docker container is not a great performance measuring device. There's a bunch of other stuff that's stored in here too. There actually is a more detailed option that can use print all stats. This is going to print a whole whack of stuff. But this will show every class that's in the cache. So if there's a class that you really care about, you want to find out if it's in the cache, you can obviously go looking through this output. Sometimes they're easier to find than others. Here, I'm going to go looking for an AOT. Oops, wrong way. Right. So if you see an entry like this, this is an AOT compiled method body for get imported sources in here in this ROM class. So you can find AOT bodies that have been compiled for methods in here, and there's going to be a bunch of those listed through here. Other things that get stored into the into the shared class cache are JIT hints. So these are hints to the JIT compiler to say what op level does this method need to be compiled at, or does it need to be recompiled to later, so that can save on compile effort in those subsequent runs and make ramp up even faster. And another thing that gets stored into the shared class cache is JIT profile data. So one of the things that we do during that first run is take the profile data that the interpreter has collected about the execution of this method and persists it into the shared class cache, so that in a subsequent run, if we need to recompile that method, we can use the profile data that was collected during the first run in order to make sure that we really generate a very good version of that compiled method. Let's see. So that's basically the summary that I was going to go through today. There are even more options that you can use to track what AOT methods are being compiled. The options that I showed in my earlier talk using -x JIT verbose actually include entries for AOT loads and for AOT compiles that look like AOT cold or AOT warm. And so those entries can be identified in a JIT verbose log as well. And hope you enjoyed it. It's the end of my lightning talk.
Thanks, Mark. Are there any questions from anybody on the call?
I have a question. So presumably there's a trade-off between how big to set the cache size and something. Why wouldn't I just set it to some huge amount so that everything just always went in the cache and I didn't need to worry about it?
You couldn't do that. I mean, it's going to allocate a bunch of virtual address space. There's also a soft MX value that I didn't specify, which is how we try to control how much space the cache actually ends up consuming. So there's a whole another set of tunings that you can do around shared cache size that can help you use the least amount of physical memory for the environment that you use. But usually we end up tuning it so that we're just using as much memory as we need for the application that's being run.
So the recommendation generally is do a few runs of presumably your production system with these various things turned on and get a good feel for what's going on and set some tuning values accordingly.
And then round up a bit, yeah. Give yourself some space. Yeah. One important thing to know about the shared class cache is that it's not technically a cache in the sense that most people think of caches, in that the things that are stored in the cache can't be ejected. But it is a cache in the sense that it's retaining information that gets used by the JVM and to accelerate things. So,
thank you.
All right. Thanks, Mark.
Yep, got it down to 10 minutes. Almost there.
Well, there's lots of information to pack into that, so.